the first scientific measurement I ever made was of electrical conductivity. I was an undergraduate student in Sterling Taylor's lab at Utah State University, and he gave me a project to do that was to measure the simultaneous movement of salt and water in a soil column. And so to monitor the salt movement, I needed to measure the electrical conductivity of the water. Now, this wasn't the electrical conductivity of a soil, it was the water, but those were, the equipment we had to make those measurements was pretty primitive. The current that we passed through the solution to make the measurement was 1,000 hertz alternating current. And 1,000 hertz is well within the audible range, so that we could just put on a set of earphones and we could listen. We could adjust the bridge and listen, and we would know when the bridge was balanced. And so that was how we made the measurements. You'd just put on a set of earphones, you'd adjust the bridge, and when the sound went away, you'd know the bridge was balanced. And so the resistance the bridge measured was the same as the resistance of the solution that you're trying to measure. So that was the first one of those that I did. One of the important times at Decagon was when our vice president of engineering returned from a trip to the Netherlands, and he said these people who are working in greenhouses need to measure not only water content of the substrate they're working in, they need to measure electrical conductivity, because the electrical conductivity is a measure of the amount of nutrients in the irrigation water that they're applying. Now, we had wanted to measure electrical conductivity before that at Decagon, but only as a means of trying to correct our water content measurements, because salinity affects the water content measurement. But when he came back with that requirement, why, I thought for a long time about how we should do that. Now, one way to do it is with just by measuring our water content at different frequencies. We can get some information out of that, but it's not a very precise way of measuring electrical conductivity. So as we considered the different possibilities, we realized that to do a measurement of that was accurate enough to know how much nutrients was in the water, how much nutrients were in the water, we needed to measure the electrical conductivity directly with the best methods that we had available. And so at that point, we started to design a probe that would do that. And we've been through a number of iterations with that probe, but our feeling is that our measurements of electrical conductivity are amongst the most accurate that anybody makes with probes, because we focused on that measurement as a measurement separate from the water content circuitry that we use.